I'm going to turn my camera off now, and then we can get it ready to record. And you're recording. Thank you.
Yes, I have started recording. Thank you very much. So my name is Jonathan Homa. I'm Director of Portfolio Marketing at ECI, and I'm here today to talk about the what I call the rise of Lifecycle Automation Systems. So I freely admit that I've coined a new term over here. This term, if you go into Google today, I don't think will come up. But there is a purpose to this because based on what I've seen happening in our industry over the last few years, in fact, I do see a new breed of system arising, which I'm calling a lifecycle automation system, even though there does not seem yet to be any sort of industry consensus on what to call these things. And I'm hoping maybe to set a trend over here, and we'll all start talking about the same thing. And so I'll give you a bit of perspective in terms of my findings, if you like, in terms of what's been occurring over the last few years in the industry, and hopefully give you some insights into these new systems and a basis for making decisions about them. So what we will be covering today, there's a few lessons, a few things that I hope you will learn by the end of this webinar. One is that automation is becoming mandatory. It's not going to take place overnight, but it's something which, in terms of running your networks over the coming years, is something that you will sort of be forced to implement just to stay competitive. The way that you'll be implementing these is by actually using what I call lifecycle automation systems. And these are, in fact, emerging now from all manner of vendors. And you will likely be implementing them in your networks, if not rolling them out yourselves. And then as the final bit of the presentation, probably the highest value, is when you're thinking about lifecycle automation, I'd like to give you some insights into some things to consider. What functions should you be automating? What is the order you should be implementing these things? What are the different ways that you could approach automation? And then what are some of the questions that you should be asking vendors of automation systems, including, of course, ECI, who's presenting today. So let's start with the current situation, or what I like to call the situation until today. So where is the value that we've been getting in terms of our transport solutions, both as vendors in terms of what we're providing to you as service providers, or as what you're looking for as service providers from vendors? And I would maintain that the bulk of the value until now has been in the network itself. It's been a relatively static network. Yeah, there are some things that can be reconfigured, but it's not something which we do on a dynamic basis. It's things which we might do on an occasional basis. But the value itself is in the network and what I call the feeds and the speeds. It's what are the client interfaces that are provided, what are the line interfaces that are provided, what are the networking protocols that are supported to provide the transport functionality. And it was essentially on the basis of the cost performance of these feeds and speeds that people made procurement decisions for their networks. On top of that, there was a network management layer, or an NMS/EMS layer. And this was very essential. It's an essential item in terms of being able to control the network. But what I would maintain that until now, NMS and EMS were mainly there in a supporting role. In other words, it's not the basis for which you made procurement decisions. Having that available to support the network was critical, was something that you needed to have as a checkmark item. But in terms of actually making a decision in terms of the value of the network, it was more just that it was there, not in terms of the differentiating features of the NMS and EMS themselves. So this situation is starting to change. So what I like to really draw out is in terms of what's driving change and what will be the effects of change. So probably the largest change is being the shift towards cloud computing. In fact, there's some predictions that in the next year or two, about 90% of all business applications, and I would maintain a lot of personal applications as well as storage, will be based on the cloud. That's a huge game changer just in terms of the way traffic is flowing from the way it has been done in the past. Another major change is virtualization. Now that's of course associated with cloud functionality because virtualization can be located anywhere in the cloud, but increasingly we'll see it in the network, probably more towards the edge for latency and performance reasons. Now, virtualization adds a lot of flexibility, but there's also studies that show that you don't get this flexibility for free. It adds complexity. And in fact, some studies have shown that virtualization can add up to 30% of a TCO, or total cost of operations, for a particular function. And then there's new technologies that are emerging, such as 5G and the Internet of Things, which will create new services and sort of new traffic patterns that are associated with these services. So when we take a look at these drivers of change, what this will do will change a number of things in terms of which first your customers are expecting. They're learning from the cloud model that they want services that are more responsive, that they have more control, that they have guaranteed assurance. And on top of that, in terms of managing your network, you're going to have new service topologies rather than sort of the nodal-based topologies that you've had in the past. You'll have a lot more complex service change with flows coming to and from various parts of the cloud. And associated with a lot of new services, you'll also see dynamic traffic patterns. So what this translates to you as a user is that you need to manage the complexity. So yes, you're going to get more flexibility, you're going to have more serviceabilities, more opportunities to generate revenues, but you're also going to have more demanding customers, and as a result of this and a more complex network, you need to manage this complexity. So what is the way that this will be done? So the general umbrella for talking about change within service provider and NREN environments, and an NREN is of course a type of service provider to your community, is digital transformation. In general, this is becoming more aligned with a cloud economy, following the examples of successful web-scale companies. But what does it mean from a practical point of view? In the past, we've talked about technologies like SDN and NFV, but those are in fact just technologies. And what's interesting to see is how the conversation has shifted, I'd say quite dramatically over the last year, towards a focus on automation. And just sort of to prove that point, a month ago, I was at the SDN and NFV World Congress in The Hague, and I was just really taking note of all the service provider presentations. And I went through every single one of them that I saw in the plenary sessions. And each one of them, without exception, mentioned automation as a pillar of their going forward strategic plans. I'm not going to talk to this slide in any detail, but you can take a look at those blue circles around the fact where I've highlighted automation. So talks about what is that automation and how it applies to their network. Deutsche Telekom talks about orchestration and automation. Docomo talks about deployment automation. South Korea Telecom talks about lean automation. Verizon talks about automated functions. And then there's a few more. We see Telefonica talking about automating deployment and operation of network services. Vodafone in the middle talking about the fourth industrial revolution and or the fourth revolution in fourth industrial revolution, and how IoT and cloud technologies are essential for automating complex tasks. And then finally, Ross Telecom, which in a fairly technical presentation also talked about how automation was key for the creation of services. So, where will automation take us? This brings us to what I would call the current situation or the emerging situation. And what we'll see here is the emergence of lifecycle automation systems to implement automation. This is not something which is going to happen overnight. It will happen over time, over the next few years. We'll see a focus initially likely on service provisioning to speed up how services are brought to customers. And there'll also be a period of time and overlap with traditional network management systems that for a while will continue to provide conventional FCAPS functions. But over time, we'll start to see lifecycle automation go into the network or more traditional network management domain as well. But most important in the shift is the shift in value. In the past, when we made decisions with respect to how we procure networks, it was, like I said in the past, it was on the speeds and feeds of the network itself, and we looked at NMS as something which was providing a supporting function. But more and more what we're going to see in the future is that value will be spread between the two. It will be based both in the network itself and then how the network automation is performed to extract that value from the network in terms of the speed with which you can provision services, the ability which you can shift the network configurations to support different traffic demands, the ability to which you can provide high availability and dynamic restoration. This will all be linked to something which takes place in the automation domain. Another aspect which we see in terms of the shift towards lifecycle automation is the move towards new software technologies that are implementing this, moving towards the cloud. So this is a theme in terms of, you'll see from a number of vendors in terms of how they're going towards cloud-native architectures. But this is really consistent with the overall direction of the industry. And again, following on the example of web-scale companies as a way to deploy software much more quickly. So what is being automated? So we can start off talking about lifecycle management itself. And when we talk about lifecycle management, there's a number of ways that this could be represented. There's a number of these types of diagrams around. We like to talk about it both in terms of a services lifecycle and a network lifecycle. So what the network lifecycle is responsible for is all those operations starting from planning, through building the network, through assuring the network, through analyzing and understanding the traffic going over the network, and then maintaining the network. But it's primarily in place, of course, to support the services. Then the services lifecycle, which would fit, if you like, on top of the network lifecycle, has a similar set of terms, although they'd be applied more towards the services than the physical or the virtualized infrastructure that's supporting them. I think the only word that's different here is provisioning, where we talk about provisioning services as opposed to commissioning network equipment. And of course, provisioning is something which is a much more dynamic type of operation. Within a particular service provider's network, you can have from dozens to hundreds, and in very large network, thousands of those instances a day in terms of provisioning services, both to end customers as well as to support internal, if you like, service and infrastructural needs of the service provider itself. So here we have an entire life cycle, again, from planning the service and designing the service through actually provisioning it, making sure that it's operating up to the SLA for the service, measuring the service, and then when things go wrong, trying to fix it as soon as possible. That's really the starting point in terms of lifecycle management, and we do this today primarily, what I would say, on a manual basis. But what we're doing is now taking these operations and moving them towards a dynamic, automated kind of environment. So the goal is to go from management to automation, and this will be for a network that combines both SDN reconfigurability for dynamic connectivity from point to point across the network, as well as for implementing virtualization for value-added functionality that sits on top of the connectivity. Now, the first step in automation is service design and creation. I don't think this will be an automated process just yet. Maybe in the future, some AI will be able to actually design services. But today, that's something which will still sort of be the starting point for the automated operations. But it will depend heavily on sophisticated tools from modeling and design. And again, like I said before, encompassing both traditional connectivity as well as virtualization. The services creation should cover the entire services lifecycle. For example, what analytics data should be collected, what are the policies associated with the service in terms of how it behaves under various traffic and failure conditions. And the greater attention that we provide towards doing service services creation properly, what I call intelligent services creation, the easier it will be to automate the remaining kinds of functions that are actually relying on or building upon the services themselves. Because if you can have a complete methodology for defining services, then a lot of the automation processes which take place later on become a matter of abstraction on top of the sort of the templates that are used for defining the services. And then what are those other automation functions? Well, there's the path computation in terms of actually what's the best path for the service across the network, provisioning the service and all the updates that need to take place to various databases associated with the service. When something goes wrong, how do you restore it? When something goes very wrong, how do you find where the fault is? And then just on an ongoing basis, making sure that you're using your network resources in the most efficient manner possible, so to continue to delay having to add on new resources. And you can do that through things such as multi-layer optimization. So the question is, who is providing these lifecycle automation systems? And the answer is virtually everyone. Since this is a sort of general industry educational presentation, I'm not going to go through names of people. Certainly if someone wanted to call me, I can certainly discuss this offline. But it's really coming from everyone. It's coming from the very large OSS vendors, the ones that have traditionally been providing those OSS solutions to the service providers. It's coming from the networking solutions vendors. So whether it's ECI or any of our other vendors in our particular space, and of course you know who all of those are, each one of these companies is coming out with at least a single type of lifecycle automation system. And these are not systems that are sort of just enhancements to their current NMS or EMS. These are brand new systems really focused on the automation functions. And then, of course, there's a number of new entrants that are picking away at pieces of this particular field, some trying to find particular niches, maybe some around planning, some around discovery, some around path computation. And then on top of that, there's a very special type of new entrant, which really is looking at the entire pie of lifecycle automation, both from an SDN connectivity and a virtualization point of view. And that, of course, is what I call the monster of ONAP, or the Open Network Automation Platform, which is being sponsored in particular by AT&T, which is a huge open source project. And I think it's something which certainly will be used by the very largest companies. I have my personal suspicions about how manageable that will be for some of the smaller companies, particularly in the NREN community. One thing to note is that there are distinctions. Not everyone's coming up with the same type of lifecycle automation system. Some companies are focused more on domain control for their own sets of equipment. Some are focused more on a multi-vendor environment, taking a look at a true end-to-end services orchestration type of capability. Some are more focused on the virtualization aspect, some more on the SDN aspect, some are specializing more on different segments of functionality. But by and large, they're all addressing the same space of automation. And I think one of the things that we'll see is that a variety of these kinds of systems coming from these different vendors are going to be needed. So how will this play out in terms of the way that lifecycle automation systems will be deployed? So here is what I'm providing with a general architectural view of how I see the control and automation landscape looking like in a few years when we've reached a steadier state from the situation today, where I'm very, very clear where we are in the earlier years. So I believe we'll see a single predominant lifecycle automation system within any particular service provider. Particularly within sort of a large geographic domain of that service provider. Maybe if they're really truly intercontinental or covering many countries, there could be a few of these sort of what I would call alpha lifecycle automation systems, but generally it'll be one. And the reason you need one is because you need to provide end-to-end service orchestration. Now, this can be coordinated between lifecycle automation systems, and this is something certainly industry forums such as the MEF is looking at. And probably between service providers, there'll be mechanisms for doing this end-to-end service orchestration. But probably within a particular service provider, it'll be easier to have a predominant supplier. On top of that, you will have multiple vendor-specific lifecycle automation systems for their domains of equipment. You can think of this as a domain controller with automation value added on top of that. So for instance, it could provide things such as path computation, automated provisioning and restoration for that set of equipment, analytics for that set of equipment, maintenance and policy management, etc. Now, communication between the lifecycle automation systems we'll see taking place based on APIs, application programming interfaces. Probably a lot of these what I would call RESTful intent-based APIs. And this will follow the example of what we see taking place in a cloud economy, which more and more is going towards an API economy, where companies can provide value through software by piecing together different islands of applications through APIs to get the job done. Now, undoubtedly, there will be competition in this particular scenario, and of course, that's going to be healthy. You'll see some of this taking place between the OSS vendors that are going to try to sort of look southbound towards the network domains. You'll see some of the competition taking place between the various lifecycle automation system vendors themselves, sometimes between, say, the end-to-end vendor versus the companies that are providing domain-specific lifecycle automation. And another aspect is NMS. I don't show NMS disappearing in this particular picture, but it's something which will start to be subsumed over time within the lifecycle automation systems. Probably you will see models where they'll be using the NMS to talk to equipment, maybe then legacy equipment, and then over time start taking on the functionalities of the traditional NMS. So from an architectural point of view, this is what I would suggest as the sort of general view that you start considering for implementation of lifecycle automation. So at some stage, you're going to get on a path towards specifying, procuring, and implementing automation using lifecycle automation systems. This could be based on a combination of existing and new vendors, as well, of course, perhaps using internal sources. There might be certain functions and certain bits and pieces that you want to roll your own, do yourself. So in this slide and the next few slides, what I plan to do is just run through some of the hints or questions that you should be asking to your vendors as well as to yourselves in terms of what are some of the things that are important with respect to automation. Well, I'll start with service automation. And like I mentioned before, what's really important for service automation is to get the service design and creation piece done right. To be as exhaustive as you can with respect to specifying this for the life cycle of the service, because what that will do is, like I mentioned before, will make it easier to implement automation that flows from that, because then you can start to do things in a more abstraction-based basis. So once you've defined your services, again, covering the life cycle, you need to take a look at service instantiation, or actually bringing up instances of those services, also called services provisioning. Here you'll need to have a path computation engine. And what I call here is a policy-based path computation engine, because you don't just want to consider, say, the traditional PC functions of shortest path. You also want to consider various policies such as cost, perhaps number of nodes based on things such as latency concerns, perhaps the underlying fibers that it flows through, so you don't have sort of common points for your restoration and protection paths. So more and more we'll start to see PC becoming sophisticated. Then, of course, the heart of provisioning will be the transaction workflow. So you need to have good transaction workflow tools that are able to actually specify the network resources, reserve the network resources, make any changes within the network resources, make any data updates to associated databases, putting everything in place before you actually as you're building the service. Again, encompassing both SDN connectivity and in many cases in conjunction with virtualization. What's important, and I really can't underscore how important this is having a rollback capability. In many cases, automation won't work. In many cases, something will not take place correctly, somewhere along the lines in terms of bringing up the service on an automated basis. Maybe there'll be 10 steps, maybe there'll be 20 or 30 steps, but you need all of them to work. And if something doesn't work and you've already committed certain resources, unless you have a very strong rollback capability, there's a good chance that you're actually going to use those resources or have them subscribed, and then they won't be free to be used for other services. So it's extremely important to have a rollback capability. And another thing which is important is to have a partial automation capability. Again, this will be a process as you go towards automating your network operations. And it's important in terms of the solutions that you have, perhaps being able to say, where do you want a breakpoint that you can have a manual verification or a manual override to some of the decisions that are taking place. Another thing to think about is SLA pre-verification. Once you've created your service, you want to be able to test it before you actually hand it over to the end user, whether it's an end customer or some internal part of the network that's looking for that particular service. And here you want to have a pre-verification capability to see that the service meets the bandwidth needs, sees that it meets the bandwidth requirements, see that it meets the latency requirements, etc. So that's something else to have as part of your checklist. Then we move on to service assurance. Here you want to be able to gather analytical data associated with that service. And again, that should be part of the service design, what you're measuring, so it's not something which is done on an ad hoc basis. And it could be used to see whether you're actually meeting the SLA on an ongoing basis rather than just waiting for some failure to occur. And then if things start to deteriorate or there's some failure in the network, how do you actually provide restoration for the service? Once you've got all those things done correctly from a design, instantiation, and assurance point of view, you're then in a position where you can start actually extending these capabilities that the customers can control these things themselves in what I call a closed loop operation, where the customers can reach into their virtual capabilities for their slice of the network or their slice of the services that they control and actually implement these themselves through a customer portal. But a customer portal is something to be done really correctly, needs to have all the above automation capabilities already in place. So we talked about service automation. What about the network? So in terms of network automation, and remember, the network is there to support the services, it starts with multi-layer network discovery. So in the services domain, it was important to define the services as completely as possible. In the network domain, it's really essential to have a comprehensive, up-to-date view of what is actually taking place in the network itself. And this really means going down into all layers of the network and being able to continually discover what resources are there and how they're being used, that you can then build on top of that in terms of actually being able to use them properly for the deployment of services. This even extends to things such as network planning, where you don't want to be able to do this on a static database of what you think the network is. You want to do network planning on an actual snapshot of where the network is today. On top of that, you then want to take a look at the optimization algorithms that are being discussed by your vendors. What are their pros and cons? And is it something which is only for a specific layer or something which is multi-layer? And then kind of what kind of tools they provide you, such as what-if tools. For instance, what if a failure occurs? What if traffic increases by 50% in a period of several weeks? What if there's some burst traffic based on some events that take place? Will your network planning and the recommended configurations be able to account for all that? What you want from your network planning then is the kinds of specifications or the kind of configuration files that could be downloaded smoothly to the actual equipment itself, that you can start bringing up equipment or changes in the network in what you would call a zero-touch type of scenario. Another way of talking about it is plug and play. Or in other words, someone just comes there, drops the network equipment off at the site, or plugs the card in, and then everything else takes place automatically, which is the theme over here. So once your network's in place, once the equipment's commissioned, ready to carry traffic, which it should be doing, everything and then moves to network assurance. And there's a whole list of things that you see over here, from configuration management, making sure that Everything is configured correctly on a ongoing basis. All the software is up to date, the settings, the policies. It's really important to have a extensive and correct checklist for configuration, because otherwise things can quickly get out of control. You need to have an capability to do mass operations on your network for policy changes. For instance, whether it's giving traffic priorities as an example, or what to do in the event of failures, how should equipment react. You want to be able to propagate that not on a piecemeal basis, but something on a widespread automatic basis across your network. You need to have good algorithms for congestion or traffic control. You need extensive capabilities for monitoring and analyzing and getting analytics and data from your network, of course, based on advanced telemetry, which is coming to the front. If something goes wrong in your network, you want to be able to do dynamic restoration. And then, of course, I've talked about multi-layer aspects. To a greatest extent, we're still taking care of the network today on a layer-by-layer basis, a packet layer or an optical layer. But increasingly, what we want to be able to do is take a look at that as a whole and try to do optimization across the various layers all at one time. And then finally, there's fault externalization. Something goes wrong, how quickly can you find it and fix it? So those are the main themes of what I call service and network automation. But there's a few other things you should be considering as well. Openness. How open is the automation solution? Say from a network point of view, how well can it cover other vendors' network equipments, if those are in your network? How well could it communicate with other lifecycle automation systems via APIs? What kind of tools does it make available, or tools that you can bring to the table to do the service modeling? And then really looking into the future, is there software functionality that can be added on by third-party vendors? Because very strong theme of way telecommunications networks are being procured today is using best of breed. So best of breed shouldn't just cover the hardware that goes in the network, but it should also extend to the software that you're using to control the network as well. To what extent are cloud native principles being used for the building of these automation systems? You are going to start deploying all your software into your sort of NREN cloud in the future. You want to make sure that things are consistent with the kind of principles in terms of which you're building this cloud, that you can start getting the benefits of what, say, such as continuous integration and continuous delivery of functionality. Security. That certainly needs its own checklist. I'm not going to get into that here. It's probably a webinar in and of itself. But just because it's sort of new and shiny, I don't think that security will take care by itself. You know, whether it's from authentication to, you know, in terms of the users that can access the software, or even the way that other applications can call upon the software itself. There's could be many, many holes within these types of systems that bad guys, if you like, can use to bring down your networks through the automation layer. So security is something which you need to pay particular attention to. Pricing, there's different models that need to be looked at: perpetual, subscription, per use. Certainly you don't want to continue paying for something that you're not using. On the other hand, maybe you, and more people are getting away from sort of buying software outright, but are buying in on some of these kinds of subscription basis. So that's something which you have to start looking at in terms of actually how you're procuring this. And then as a final thing, you'll start to hear a number of people start talking about why their automation systems are the best, because they're based on some artificial intelligence or machine learning kinds of algorithms. And in fact, you might start to see some early instances of AI or ML, but from what I've seen so far, they're really just talking about algorithmic approaches. But they'll start to come out. But my main warning over here is don't judge by the hype, judge by the value that they're providing. And then the final consideration that you should be given when you're looking towards automation is migration. no one is really deploying a greenfield network today. And in terms of your network and the automation capabilities that go on top of it, there are many types of migration questions that you need to consider, both in terms of how you'll migrate from existing operation and business support systems, how you'll migrate from existing network and element management systems, and how you'll handle legacy network equipment, perhaps that can only partially be covered within automation scenarios. So again, this is just the set of questions that you should be asking yourself when you're putting automation together. Because if you start automating certain parts of the network and you don't think about how this is going to react or interact with non-automated parts of the network, you could find yourself in a situation where actually you're causing yourself more harm than good. A couple of slides to finish off over here. Since this is an ECI presentation, I'll give a very quick plug to what ECI is doing on the automation front. We have a suite of software which is called the Muse Orchestrator, which is part of the framework for our Elastic Services platform. This is a fully cloud-native implementation for automation, focusing on adding automation value to ECI's sets of optical and packet transport equipment, provides both services application for speeding up service delivery, network applications for assuring network performance, and even providing mechanisms for adapting third-party applications. It works very closely with our existing network management system called Lightsoft to really facilitate migration of your management solutions towards automated solutions. And it features powerful northbound APIs to integrate with existing OSS and BSS and other higher levels of orchestration orchestration and automation that you might be implementing. So this is how ECI is focusing on helping our customers enhance their networks through automation using the Muse Orchestrator. As a final thought, before perhaps we'll get into any Q&A, is I'd like to really just mention that automation is a means and not an end. I really like this quote by Bill Gates. Talks about that you need to look at your operations first and where it makes sense to automate functions. And because if you do it the wrong way, what you just end up doing is increasing the inefficiencies. But if you have your operations nicely defined, what you'll end up doing is really giving yourselves a big boost in terms of the benefits that you can provide to your network. So the closing message over here is that automation is a means and not an end. You need to start taking a look at what's important in your particular network from a services provisioning point of view, which customers are important, which customers might need automation first, what services might need automation first, what parts of the network in terms of the planning and assurance functions need automating first, and then you can start putting together a plan and figuring out how you want to start implementing that. And on that note, I'll say thank you very much. I'll go back to this slide over here, and I'll see if we have any questions in the chat panel, which has not been opened.
Thank you very much, Jonathan. That was really very interesting. If anyone has any questions, then please do ask. I have a quick question about this. Is obviously within the NREN environment, we are a multi-domain environment where we have users connecting to an NREN, connecting to GEANT, connecting to another NREN, connecting to another part of the user. How would, with those being heterogeneous networks with different providers, vendors, and so forth, how would this operate in that kind of environment? Is there a way of doing that in that kind of multi-domain environment?
You're talking about between multiple operators? Are you talking about operating across NRENs, or?
Well, if you have a user in one country and they need to connect to another department in another country with with services, then you've got an NREN in one country, you've got the GEANT backbone, and then you've got another NREN in the second country, and then you've got the users and the ends of those. So you've got this multiple domains here because each of us control our own networks, and we're not going to have the same environment across all those networks in terms of hardware or software or whatever.
Yeah,
So multi-domain environment is the key issue for us.
So the answer to that, and I mentioned it earlier, there's actually a lot of work taking place within the MEF, which is defining the types of AP interfaces and APIs that sit on top of those interfaces that can be used for end-to-end service orchestration between service provider domains. Actually, ECI as a company is deeply involved in that particular area. At the last MEF, which took place a month ago in Los Angeles, actually, we worked with 4 different service providers to actually show. We actually won an award for this at the proof of concept that we had over there for creating dynamic services across 4 different service provider domains spanning 3 different continents, implementing the MEF interfaces. And this is something that I talked about actually at the last TNC. So this is something which I'm hoping that the NREL community will start availing themselves of, because these are things which are available for them to use. So as they start implementing automation and orchestration within their own domains, there are mechanisms that are out there that will enable this to occur between domains, which really is needed by the end user community, which, like you say, is spanning many different geographic and vendor and service provider domains.
Sounds like an ideal opportunity for a Plugfest going on there. Absolutely.
Well, you can try that if you like.
Indeed. That's great. Thank you. Does anyone else have any questions at the moment?
Yeah, I've got a question. This is Toby here. Particularly when it comes to pick up on Carl's point about heterogeneous working and the like, and Jonathan, you mentioned about the importance or potential importance of openness and interoperability between vendors and providers. So it seems to me that for automation to work well, it's going to have to use some well-established, robust, and commonly used models, particularly of network systems and the like. And I know there are several out there, and I was wondering if you had a view on which ones have become the most well established and the sort of lingua franca of requesting services and configuring systems.
Well, you know what, this is probably a good opportunity. I have my colleague on, Monty Cohen, who's our product manager for this, if I can unmute him. Monty, is this an area you'd like to chime in?
I hope you can hear me well without background noise. That is the case that
There's a bit of background noise, but give it a go for a minute.
Okay, so Toby, if you can shortly repeat the question.
Sorry, Marty, did you say did you want the question again?
Yeah, shortly, please.
Yeah, okay. So I was just thinking that, particularly with regards to interoperation between heterogeneous networks, different service providers, and what have you, and desires for openness between providers, so that a single request can filter down and provision services across a heterogeneous network. I imagine that it's going to be very important to have well-established, very robust and reliable network models to model the network and the services very well. And I'm aware there's a number of models out there. I know that, for example, the TMF have got the TMF frameworks is one. But I was wondering if you had a view on whether there were any particular models that were becoming well established and would become the sort of de facto standard, or indeed the standard that automators would adopt and adhere to.
Yeah, so, okay. First of all, about the standards. So, as we know, standards are there, some are using them, some are not using them, and with the time, they're going to be changed. what is going to be changed, and this is what we're so optimistic about those integrations between systems, is that the interfaces became more abstract. It means that, and that's a good example that you gave for the TMF. TMF for years developed information models that are very detailed, and they included everything about the configuration, the monitoring, the inventory information, performance. They included everything, and the more you have data types and information in the model, the harder it is to achieve an integration between parties, because each one of them, they are taken apart from the standard, and it's very difficult to align them all. With the abstraction that is taken now by MEF and by the ONF, interfaces are more abstract. It means that if I would compare, for example, an API to create a service with what I had in the past for the TMF, which included, I don't know, tens of different attributes, then what we see now is an interface with very few attributes. There is a template that we use, and we just give reference to the name of the template, and the rest of the parameters, they're just the unique ones of the service, without referring to the full details, the full model of the service. That makes it more easy to integrate between vendors. And even though they will not be aligned with the same standard, then still integration phases will be shorter.
Yeah, Moti, it's a little bit hard to hear you. What I'm going to suggest is, because I think you have a lot to add over here, is perhaps for the participants over here, if you can put something down in writing, maybe you can follow up with Toby directly, but it's a little hard to hear you from the environment that you're in. Sorry about that, Toby.
Oh, no worries. I appreciate it. Yeah, absolutely. A sort of a short message would be ideal. Thanks very much.
Okay. Yeah, and I'd rather Moti, since he started, finishes off with that answer. Okay.
Okay. Does anyone else have any questions for Jonathan at the moment? I'm not seeing anything coming through on the chat. Anyone wanting to ask any questions at the moment? Okay. I think that probably means that we are finished for the moment. Thank you so much, Jonathan. What we will do is, everybody, we are recording this session. We will edit the session down very slightly to take out some noise and stuff like that and bits and pieces, and then we will publish it with everybody's permission, with Jonathan and Moti's permission, and let everybody know. And I would like to thank you all for turning up, and I would particularly like to thank Jonathan for the effort he's put into this. Really fascinating subject, and hopefully I've learned a little bit myself, and hopefully some other people have learned stuff as well. So that's been really, really useful. Thank you so much.
Thank you all. Appreciate the time.
Thank you, Jonathan. Much appreciated.
Okay.
Thanks very much, Jonathan.